This is another application of combinations video. In this one, we're looking at marbles in a bag, and we want to, when considering these, we want to think about all the ways that we can select different types of options, and we just use combination theory to do this. So, for instance, on this is the first example here. It says consider a bag that has 7 red, 8 green, and 5 blue marbles. And then it asks some specific questions about this bag. And it says, first one is, how many ways can 3 marbles be selected? Well, you've got 7 plus 8 plus 5, which gives you 20 total marbles. And you want to select 3 of them. And so it's very easily, or simply, 20, choose 3. You got 20 marbles, you want to select 3 of them. It's a very direct application of combination theory. So you do 20 times 19 times 18 divided by 3 times 2 times 1. Denominator 6, which cancels with the 18. And so you end up with 20 times 19, which is 380. And then you multiply that by 3 to get 1140. And so there's 1140 ways that you can select these 3 marbles. Now, notice this is assuming that these marbles are distinguishable in some way or another. They just have a similar color, but they are different from each other. The next one says, how many ways can 1 marble of each color be selected? Well, this one, there's 2 ways to think about it, but using the combination, you just select 1 of each of them. And so you say 7, choose 1, and then times 8, choose 1, times 5, choose 1. You want to select 1 of the red, 1 of the green, and 1 of the blue. Well, whenever you choose 1, that just gives you the number, so it does just turn out to be 7 times 8 times 5, which equals 280 ways. And so there's 280 ways to make these selections. Now C gets a little bit more complicated because now we're selecting 2 of the green and 3 of the red and 2 of the blue marbles. So we start with 2 green, so we're going to start with 8 choose 2, so we're going to select 8 green marbles. And we want to choose 2 of them, and then we want 3 red, and so we're going to take, of the 7 red marbles, we want to choose 3 of them, and then of the 5 remaining blue marbles, we want to select 2 of those. And we multiply this together. It's an application of the fundamental theorem of counting, which just says, because the ways that I can select the 2 green marbles are independent of the ways that I can select the 3 red marbles, are independent of the way I can select the 2 blue marbles. So I just calculate each of these out. 8 choose 2 is 28. 7 choose 2 is just 7 times 6 times 5 over 6, and so it's just 7 times 5 or 35. And then 5 times 2 is just going to be 5 choose 2, which is always going to be 10. And then you just multiply the 35 times the 28, and you can do that on a calculator, and you get 980. And then you do 980 times 10, which is 9,800. And so interestingly, there are way more options for selecting 2, 3, 2 of each of these types of marbles. And then these problems get a lot more complicated after this, but this is the general theory that you're going to use to solve these type of combination problems.